Hello, everybody. So in this session, I'm going to cover one of the important protocol that is TCP, and it is very, very widely used. Very, very widely asked question in the interview. It does not matter like which level of interview you are giving, like L1, L2, L3, even for L3, L4, and it is also useful for other people who is working in different field, maybe in developing field. So maybe they got the requirement related to any application to develop where TCP is required. So this session is useful for everybody, even for non-technical field people also. Okay. So in this session, I'm trying to cover TCP history, TCP compared to UDP, and then connection oriented define and TCP header fields. And then upcoming session, that in next session, I'm going to cover like there is one important concept as TCB, transmission control block, and the three handshake process. Okay. Uh, it depends upon time, guys. If like we have good times, then I will try to cover in this session. Otherwise, I will upload one separate session for that. Okay. So let's try to understand the TCP history, guys. So TCP is basically developed by Stanford University in 1970. Originally, TCP and IP were part of the same standard called TCP, Internet Transmission Control Program. Okay. Later, IP and TCP was decoupled to each other. Later, IP was a part of layer 3, and later, TCP was a part of layer 4. Okay. So IP, the protocol suite, ARPANET was the network infrastructure, and TCP was decoupled from IP to stay consistent with a layered approach to networking. So for the layered approach in networking, they decoupled IP and TCP to each other. From each other, we can say TCP are the part of layer 4 and IP is the part of layer 3. So this is the history of TCP. Okay. Then if we compare from TCP compared to UDP, so what makes TCP different from UDP? So UDP is basically connectionless, guys. UDP has not the guarantee to acknowledge your data, whatever receive or not. Okay, and there is no reliability or retransmission in case of UDP. Okay, but in case of TCP, guys, it is connection oriented. What is connection oriented? For example, this is source and this is destinations. So before sending data from source to destination, first is going to, you know, create the connections. First trying to, it will know the peer, like who is that peer, then it is going to send the data. So that is all connection oriented. Okay, and TCP can work with any format of data, including a constant stream of byparts, constant stream of bytes from upper layer protocols. Okay, it's provide reliability with acknowledgement and retransmissions. For example, if you are sending anything to the sender from source to destinations, for example, whatever data we have sent from source to destination, this is not maybe received. There is no any acknowledgement for that data. So it is going to retransmit that data again and again, again and again until getting the acknowledge for that data. So that is called retransmissions. So this feature is available in TCP but not in UDP. Okay. So this is the difference between TCP and UDP, guys. Okay. I mentioned like what is the meaning of connection oriented. So connection oriented basically TCP verifies existing so peer prior to data exchange. So first source is going to, we can select sender and receivers. So sender is going to be verify to peer prior to exchange the data in between. So that is the meaning of connection oriented. TCP peers negotiate parameter used to control data exchange. TCP data is exchanged reliably using sequence numbers, acknowledgement number, flow control, and retransmissions. In flow control, we can see other stuff. I will try to show that. Acknowledgement, sequence numbers, everything is happen in the case of TCP. So that is called TCP flags, where we can see like push flag, pin, scene, sequence. We can say like scene flag, we can say acknowledgement flags. Then we can say like urgent flags. So these are the part of TCP flags. Okay. TCP can gracefully inform peer of the need to close connections. For example, there is communication between source and destinations. If there is no any data sent from the source to destination, this is going to be tell to peer, okay, I want to close the connections. So this option is available in TCP. So TCP can gracefully inform peer of the need to close the connections. If there is no any data to transfer, both can be close to each other, and that is the part of HIN flags. So HIN is the good way to terminate the connections. So this feature is available in the TCP, guys, but in not the UDP. Okay. And these are the header fields. So we have source port, in TCP of destination port, sequence number, acknowledgement number, we have control flags, and I'm going to explain the control flags also. Then we have window size, then TCP checksum to identify the data, urgent pointer, if urgent pointer is set, it is going to send the data immediately without following the buffer process. And then they have actual data, that is your payload. So this is the header. Sometimes it will also ask an interview about header also. Okay. Window size, little bit I'm going to tell guys. So for example, this is the client and this is the server. So for example, this is the receiver consider, and it is telling to sender my window size is only to receive 50 segments kinds of data we can say. So big data is going to be divided in multiple segments. So please don't send the data more than 50. So that is called window size. See, window size is 50. Only the sender can send 50 segment to these receivers. Once this window size is blank, we can say free, then other data can be sent by the sender. So this is called window size. Window size indicate how many data, how many segments I am willing to receive from sender. Okay, so that is the called window size. Okay, guys. Purpose of three-way handshake, guys, because the main objective to hands off is like initial contact and proof by existings, like actual meaning of three-way handshake, like I'm going to know the peer before sending the data. Okay, sequence number for synchronization, exchange of parameters. So that is the purpose of three-way handshake. Okay, this part I'm going to cover in next sessions because this session will be long. I don't think like this features is available anywhere, guys. This is the inherent features in the TCP. I think no one is going to explain you and tell you. This is TCP transmission control blocks, and I'm going to upload one separate session for this. Okay, so this is the inherent features in the TCP, guys. Okay. Before that, I want to so like about the flags, TCP flags, which is very important to understand, guys. So we have like urgent flags. So whenever flag is set, urgent flag set to 1. The urgent pointer field in the TCP header specify the position in the data stream where urgent data ends. So when communication happening between sender and receivers, and whenever we are able to see urgent flag, guys, it indicates that the data being transmitted contains urgent information that we proceed immediately. So in case of urgent flags, data can be proceed immediately without following the buffer process. So what is the standard process of TCP, guys? For example, if you want to understand the urgent pointers flags, let me explain little bit. What is the flow if urgent flags is not there? So what normally happens without urgent flags? So in a standard TCP communication, guys, incoming data is typically stored in a buffer at the receiver end. So whatever data is sent from sender to receiver is going to be buffer that data, and the receiver process the data sequentially, ensuring proper order and reliability before handing it over to the applications. So it is going to be stored in the buffer and follow one by one sequentially. If we set the urgent flags, it is not going to follow the buffer process. It is going to send it or transmit it immediately. So that is the meaning of urgent flags. Anyone can ask in the interview related to these flags, and we can answer like that, guys. Okay. So it is going to transmit contains urgent information that should be processed immediately. It is not going to be follow the buffer process. Okay. Then second class, guys, we have acknowledgement fields. Okay. So acknowledgement is used to confirm the successful receipt of data. For example, I'm sending, I want to build one connection to you before sending the data. So I'm telling to you, hi server, this is my sequence numbers. Please add one and send as acknowledgement so that I can understand, yes, you have received my sequence number, you have received my informations, and we have added one to my sequence number and we have sent me as acknowledgement. So acknowledgement is the flags in TCP is used to confirm the successful receipt of the data. Okay, so it is very important to understand. Okay, then we have push flag, guys. So push flag basically push flag signal the receiver to pass the data to the application layer immediately rather than waiting to fill the buffers. For example, communication happening, data transfer happening between sender and receivers. So whatever sender send to receivers, and if for that packet, for that segment, for that data, in flags, if push is set, it is going to tell to receiver, please send this data, please pass this data to the application layer without waiting the buffer process. Okay, so this is the meaning of push. So whenever generally we do capture in the Palo Alto in the checkpoint, like with the help of TCP DOMs in case of Palo Alto, um, packet capture in Palo Alto. So when we run in TCP dump in case of checkpoint or maybe Palo Alto with the help of packet captures, we generally see sometimes push packet. So push packet indicates guide it's like good things in the TCP. Push packet indicate that data is received. Data is received received to send receiver and it is sent immediately to the application layer. Means data is already received by receiver, also sent to the application layer. So this indicate about push packet. Okay. So this is a push flags, guys. Then you have reset flag, guys. So reset basically flag is used to abruptly terminate a TCP connection when an error or unexpected condition occurs. Okay, so this flag is often set, for example, communication happening between sender and receivers. For example, receiver is not listening on the port, for example, 80 or 443, and sender is want to build the relation on connection on port 443 or 80. At that times, it is going to tell in that segment, I want to, it is going to use the reset flag and it will going to terminate the connection, reset the connections. Okay, so reset is not the good way to terminate the connections. If you are able to see the reset, sometime it is good, sometime it is not good. It depends upon the situation, it depends upon the issue, guys. So if a server receive packets for a connection is no longer recognized, okay, communication happening between client and server. If server receive packet for connection is no longer recognized, it might send a segment with the receive reset flag to inform the sender to reset the connections. Okay. Then we have SYN badge. SYN is basically, SYN flag is basically synchronized sequence number connection setup. So SYN is basically used in initial stage when when a client is start building connection with the server. So it is going to use one sequence numbers, we can say randomly, and it is going to send to the server like this is my sequence number. Please add one in sequence number, send back as acknowledgement so that I can understand you received my sequence number. And also, please send your sequence number in my direction so that I can add one in your sequence number and send back to you. So that this is our we can say like three-way handshake will be completed. A scene a cake. Okay. So scene is basically we can say the flags. It is used in the initial to set up the sequence number and send to the server. Okay. Then we have the pin flags, guys. Okay. So fin is basically the good way to terminate the connections. So whenever you are able to see fin in the packets, for example, you are analyzing any packets in the Wireshark, and if you are able to see the fin flags, so fin is basically good way to terminate the connections. So for example, whatever data sender already sent to receivers, there is no any data to sender to send to receivers. At that time, sender can send the fin flags. Okay, I want to terminate the connection. I want to close the connection because there is no any more data to send to you. So if you are able to see fin packets, this is the good way to terminate the connection. So this is the good sign. Okay. So when the fin flag is set, the sender informs the receiver that it has finished sending data. Okay. And let me show like how fin-ack happens. So many people are also confused like TCP three-way handshake, but in fin case it is four-way. So how it is happen? Let's see. So fin basically the sender transmit a segment with the fin flags. Sender is going to transmit a segment. Segment is kinds of data, guys, with the fin flags to indicate it has no more data. Okay. So sender is going to initiate fin. We can select send segments of data where it is going to use the fin flags, and it is going to indicate that it has no more data. To whom? To receiver. The receiver going to acknowledge that fin segment whatever sent by the sender. Okay. Then receiver sends his own fin segment. Then receiver is going to send its own fin segment when it is ready to close the connections. Okay. So in first case, sender is going to send, and in second things, receiver is going to acknowledgement it, and then again receiver is sends on fin segment when it is ready to close the connections. And then again sender is going to acknowledge like yes, let's completing the termination. Let's completing the termination. So this is how four-way fin work. So fin is the flags, TCP flags, and it is used to terminate the connection, and it is good way to terminate the connections. So this is about TCP and its flags, guys. So I hope you guys really understand, and I hope this video is useful for you from the knowledge perspective. Before closing this session, let me show little bit in the before closing session. Let me show little bit in the Wireshark also. Okay. So this is seen, guys. So this is source 10.0.0.0.145. Let me take the pin. Okay. So this is source 10.0.0.0.145, and it it want to make the connection. You can send establish the connection to the destination 186.15.230.24. Okay. So this is the source. This is destination. Come to the layer 4. Source port this, destination port 80. And this is the sequence number. Sequence number 0, basically it's Warsaw term, guys. Please ignore this at the moment because I'm trying to explain you scenic part. So how, and it's widely asked in the interview also. So source is sending, this is my sequence number. Okay. Scenic during this period, there is no any data will be sent. This is just for the establishing the connections. Okay. Let's see on the second packet. Please remember the sequence number is 183 is sent by source 145. Okay. If you go on the second packet, guys, see, in acknowledgement number, it is adding 184 on the sequence numbers. Whatever sequence number is sent by 145, 232.24 destination is added one number in that sequence number and it's sent as a acknowledgement. That is 184. Let me show you again. See, 183 and it is sending this sequence number as a acknowledgement 184. It means that sequence is received by sender. So received by we can receiver. And receiver is added one number on that sequence number and sent back to the sender. And it is going to use its own sequence number 292 in the direction of source. So this is the sequence number, new sequence number set by the receiver. And the third packet, source is going to add one on their sequence number, guys. See, 293, and it is going to send acknowledgement. See, 293, and it is going to send as acknowledgement to the receiver. And in sequence number, it's using own sequence number, not 183, 184, which is sent by receiver in the second packet as acknowledgement. So that is using that sequence number is used by we can say like sender, and whatever sequence number is set by receiver in second packet, it is going to send as acknowledgement by adding one number. So this is how both know, okay, whatever sequence I send, you added one and send as acknowledgement, and whatever sequence number you send it, I added one and send as acknowledgement to you. So this is how both build connection to each other. So after TCP handshake, guys, then SSL handshake generally happen, then actual data transfer between client and server. Okay, so this is how TCP handshake work. Okay, so I hope this session was really helpful. If yes, please share, like, subscribe as much as possible. Let's meet on the next session. Thank you very much. Thank you very much for your time.